Hey guys, it's Mr. Grady. Welcome to another edition, a Monday edition of CMA Math Academy. Let's get into what we're going to be learning today, why we're going to learn it, and how you will know if you're successful. So here we go. Today we're learning how to analyze scatter plots of bivariate data. So scatter plots are something you've heard, I'm sure. Maybe you haven't heard bivariate data. We'll talk about what that means here in just a second. So why are we learning this? Because data comes in many different forms. We've talked about tables, we've talked about graphs, we've talked about equations. Scatter plots are just the next piece of data we're going to analyze. So it's just the next thing we're learning. And then finally, how will you know if you're successful, if you've got it, if you've learned it? So at the end of class today, you're going to be given a scatter plot, and hopefully you'll be able to draw a trend line, so we'll talk about what that means, determine clusters and outliers, and answer questions relating to the data. Alright, so let's get started with our activity. You won't need your book today. Mr. Schrag and myself, we're going to give you everything that you need. So hopefully you have some graph paper. You will need that here in just a minute. But otherwise, just be ready to learn and listen. Okay? Here we go. Alright, so one of our words for today is bivariate data. So everyone's going to repeat that after me. Alright? Everybody say bivariate. Say data. Nah, we need everybody. So everybody's going to say it. Ready? Bivariate data. Alright, so that's probably a word we haven't heard before. So instead of just telling you what it means, I'm going to kind of lead you through some other words that sound kind of similar to it, and then hopefully you can figure out what bivariate actually means, okay? So let's talk about this. The first word that's similar or has something in common with bivariate data is bifocals. So maybe you wear glasses. Hopefully you don't have bifocals. Most of the time bifocals are for people who are older in age or just have really, really poor vision. So a bifocal has two different sets of lenses built into them. So there's a section of the lens here, as you can see on the diagram, that's for distance. Then there's a second section that's for up close, or in this case it says reading. So bifocals have two lenses in them. Okay, so again, one for seeing up close, one for the distance, and it's on both sides. So if you're the person wearing these, if you wanted to see far away, you'd look up top. If you were wanting to read something up close, you'd use this smaller part of the lens that's inserted. So again, bifocals, two different lenses put into one section. Okay, let's look at the next part. Bicycle. So when you were young, and maybe you still do, that'd be awesome. Bicycles are great. You probably had a bicycle. So a bicycle obviously has one and two wheels. In fact, this might be one of you right now, looking like a monkey. So we got a first wheel, second wheel. Bicycle has two wheels. Then the last one we're going to talk about is a bicep. So everybody has a bicep in their arm, and the reason it's called that is because this muscle, this muscle actually breaks off into two parts up here by your shoulder. So it's one muscle that connects down here by your elbow, but it splits off into two muscles that attaches your bicep to your clavicle over here, your shoulder muscle, or your shoulder bone, I should say. So it's called a bicep because there's two muscles that attach it. And actually, come to think of it, Mr. Schrag, did I just say bicep? So now that you've had a little background knowledge, I want you to answer these two questions with your shoulder partner. So the first question is, what do all of these words have in common? And then the second question is, based off of these words, what do you think the meaning of bivariate data is? So I'm going to give you a minute here with your shoulder partner. Just discuss this, answer these two questions. Ready? Begin. All right, so let's see how we did. So if we look at what we have here, all of these words have the same prefix. So we have bivariate data, bifocals, bicycle, and biceps. Also, all of these words have something that means two. So bifocals meant two lenses, one for seeing up close and one for seeing in the distance. Bicycle meant two wheels. And biceps, remember, have two muscles that actually attach into our shoulder muscle. So sorry, it's one muscle that splits off into two sections to attach into our shoulder muscle. So using those things that we just learned, we come up with this definition for bivariate data. So bivariate is data that shows a relationship between two variables. So hopefully you came up with that. That bi in bivariate means two. So we're talking about two different things or two different categories as we're going through our information on our scatter plot. So let's take a look at a scatter plot. And a scatter plot is really exactly what you probably think of when you hear scatter plot, and that's where we have a graph or a plot where all of our points are scattered around. So normally on a graph, we try to connect our points. So if I try to draw a line and connect these points, really it would just look really crazy. So that's why we do not connect them. So on a scatter plot, you will not connect the points from one place to the other. A couple things I want to draw your attention to. The first thing is, remember, we said bivariate data is two pieces of information or two categories put onto a graph. So if we look at our graph over here, our scatter plot, on our y-axis we have visitors. On our x-axis we have average daily temperature. And again, this is talking about beach visitors overall. So that's the overall title of our scatter plot. I also want you to notice something on our y-axis. Now, most of the time when we talk about scatter plots, you guys are going to be doing a lot of the labeling on your own. So I want you to notice that they're counting by the same amount every time. So it goes from 75, adding 75 to get to 150, adding 75 to get to 225, adding 75 to get to 300, and so on. Same thing over here with our x's. It goes from 0 to 80, 80 to 84, 84 to 88, so they're counting by plus 4s every time. So when you guys have to label your x and y axis, make sure that whatever you decide to count by, you stick it out and you count by the same thing, same amount, every section. So it's not like they went 75 and only added 20, then the next time they added 15, then the next time they went back to 20. No, they stayed adding 75 this whole time, or adding 4 this whole time, okay? The other thing I want to point your attention to is this little squiggly line on the x-axis. This is called a break. Everybody say break. So we're going to talk about why this is here, what you do with it, when you can put it in your graph, everything like that. So we're going to have a break in our scatter plot here in just a moment. Okay, so now let's try some work together. So before I go to the next slide, you're going to need some graph paper. So I know you guys have been kind of just listening a little bit. Now it's your turn to actually write. So if you don't have graph paper, get that handy. And we're going to take a few notes here over scatter plots. So I would like your paper to be vertical. So the 3 holes on your paper should just be on the left side. So this is just like normal if the graph paper has holes. If it doesn't have holes, then it's just going to be a vertical piece of graph paper. And at the top of your graph paper, you're going to write scatter plot notes. So we're going to take some notes a little bit. Really all it is just practicing together. And then I'm going to give you about 2 minutes to draw out this table. So I know it's kind of a lot of work here. I'm going to give you guys 2 minutes. Go ahead and draw this table up at the top of your graph paper. Alright, so hopefully you've had a chance to copy this table down. Normally we're used to seeing our tables vertically, where X is on the left side and Y is on the right side. This is just written out horizontally, but the information is still separated the same way. The top row will always be our X values, so days absent, and those numbers represent the X's. The second row, where it says student test score and percent, those will be our Y's, so go ahead and add X and Y to that. So as we start to draw out everything on our scatter plot, I want you to think about something for a second. So all of the numbers in this table are positive. Every single number is positive. So it really doesn't make sense for us to take our ruler or our straight edge and draw a graph like we normally see. because we don't need any negatives. So that takes out all of these other quadrants. So the only quadrant we need to draw is quadrant 1. So you're going to take your ruler or your straight edge, and over to the side, I want you to draw a y-axis and an x-axis. This needs to take up about halfway down your page. So the bottom half of your page, leave open because we're going to take a little bit of notes and we're going to answer a few questions. So if you're unsure, you can follow mine. So I'm going to draw a y-axis. Then I'm going to draw an x-axis over. So I'll give you a second to do that on your paper. Okay, so now let's talk about labeling our different axes. Remember, bivariate means we have two different labels. So our x-axis needs to line up with what our x value is up top. So our x is our days absent. So down below here on the x-axis, so here's our x-axis, we're going to have a label that says days absent. Okay? And then our y-axis label should say student test scores in percents, or what we're going to say is just test scores. So we're going to shorten this up a little bit. Test scores, although we will put the percent sign so we know what our label is. So test scores and percents go on the y-axis. Okay? So remember what we talked about earlier about counting by the same amount every time. Let's look at our x's for a second. So our x's go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 10. So this is going to be pretty self-explanatory that we want to count by ones. So I'm going to give you a second, and while I start counting on my x-axis, I want you to do the same on your x-axis. Remember, we're using graph paper to help us count, so make your lines and your labels on a line that's already there. So while I'm working, you're working, we're just labeling our x-axis 1 to 10. Alright, so I have my x-axis labeled 1 to 10. And I am going to go back and I'm going to even highlight or mark over the boxes that I'm using. So I'm marking right on that line that's already there. Okay. Alright, so let's look up here at our y values. Now if we look at what y's are counting by, it goes 96, 93, which is a difference of 3, to 85, which is a difference of not 3, obviously, that's a difference of 8. Then down to 84, which is a difference of 1. So you can see these are not going by anything that's the same every time. So the one thing we do want to look at is what's the biggest y value and what's the smallest y value. So if we look at this, our biggest y value is 96. Our smallest y value is 21. So that means our graph needs to fit all the way up to 96 and all the way down to 21 needs to be on there. Okay, so the other thing I want you to notice is if we look at our table, a lot of our values are really close to 5s. So 96 is very close to 95. 93 is very close to 95. 85 is directly on 85. 84, very close to 85. 80, 90, 75, 65, all of these are very close to 5. So that tells me I want to count by 5. Now remember, our smallest amount on here was 21. So that tells me I'm not putting any points lower than 21. So if you remember earlier we talked about a break, it's that squiggly line. We're going to put a break in over here on our y-axis. So what you're going to do is you're going to come over here to where your y-axis starts, and you're going to take your eraser, and you're just going to erase a little bit of your y-axis. We're just going to erase a little bit, okay? Then what we're going to do is we're going to go ahead and put a squiggly line in there, which we know is a break. What a break does is it allows us to skip ahead to what we need, but still be able to count by 5s. So I couldn't just skip to 21 or to 20, actually, since that's a 5 amount, because that's not counting by 5s, that'd be counting by 20. But with this break, I can do that. So that means that the first amount that I have to list is 20. So I'd go 20, 25, and I have to go all the way up to fit 96 on there. So we know that 95 isn't going to get the job done. We have to go all the way to 100. So I'm going to give you a minute here. finish labeling your y-axis all the way to 100. All right, so I have mine ready to go. I'm going to give you just a second to get to yours. All right, so let's start putting some of these points on here. We've had a lot of practice with just graphing points, so I'm only going to do a couple, and you're going to take over and finish this up. So if we look, remember, our x value is the days absent, so we're going over to 0, which isn't moving at all, and up all the way to 96. So our first point is over 0 on the x-axis, up all the way to 96, which is just above 95, and putting our point. So go ahead and do that. So over 0, up 96, and we're putting a point right there. Okay? If we look at our second ordered pair, remember it's just vertical now, it's over 1, up 93. So I'm going to go over to 1, all the way up to 93. So go ahead and do that and put a point. So 93 would be in between 90 and 95. I'm going to put my point. Okay? And I'm going to do one more and then let you guys work. So we're going over to 2 and up to 85. So over to 2 and up to 85 to put our point. So 85 is perfectly on a corner for us. Okay, so here's what we've got. All right, so I'm going to give you 2 minutes here to finish putting all these points on your graph. Go ahead and do that. All right, so I want you to check your graph with mine. So it should look very similar. Now, depending on how you spaced yours out, it could look a little bit different, a little bit more clumped together, and that's totally fine. So let's look at a few things on our graph. First of all, remember, this is called a scatter plot because the points are all scattered around. We wouldn't want to connect them because it would definitely not form a line that was anything we want to mess with. We don't want to work with anything that would be this crazy or this non-linear. Okay, so we have these scatter plots that are all around. So let's talk about some vocab words. Remember, we called this part down here a certain word. So on 3, we're all going to tell what this squiggly line down here was called on 3. Ready? 1, 2, 3. Hopefully you said the word break. This is called a break. Okay, so here's the word break. Okay, then the other thing we're going to learn, or another word we're going to learn, is this word called outliers. Everybody say outliers. So an outlier is any point that really just doesn't fit with what our graph is saying. So if we look, we have a couple points that really are kind of weird. So we have this point down here, down at the bottom. It's 10, 21, and we're going to write the word outlier. Okay, and we have one other outlier, which would be this point kind of up at the top, which is at 5 and 90. So this is our other outlier. So again, an outlier is a point that really just doesn't go with the rest of our data. So if you look, the rest of our data is kind of moving at a negative slope. So it's kind of moving, if we start from the top of the left, it's kind of moving down, except for this weird point. And then this weird point is a big old drop off. So those are called outliers. The other word we're going to talk about is cluster. Now, it'll be easier to see the clusters by looking at the table. So on the cluster, we're looking for any points that are really close together. So like over here at 7, 8, and 9, we have 65, 63, and 62. Those points are really close together, which are these 3 points right here on mine. So we're going to circle those 3 points, and we're going to label that a cluster. So a cluster is any time you have points that are really similar or really close together. Okay, the last vocab word we're going to talk about is a trend line or a line of best fit. It could be called either thing. So remember, we said we don't connect all of these points, but what we do want to do, or what we can do, is we can draw a line that shows which direction they're moving. So again, if we look at ours, it kind of starts up top. So if they're gone 0 days, they got a pretty good score. And then as their absences get bigger and bigger, 1, 2, 3, 4, 5 days, their scores start to drop. Okay. Now again, with a line of best fit or a trend line, you're not going to be able to connect all the points. So your job is you're just trying to pick a point that, or pick a line, draw a line that would go through as many points as possible. So I'm going to demonstrate this for you. So if I started here at 96 and started to draw a line, again, I'm not hitting every single point. I'm just showing which direction the information is moving. Okay? So go ahead, and I want you to use a straight edge and draw a line similar to mine. And again, we're going to label this a trend line, or it's also called a line of best fit. So if you hear a trend line or a line of best fit, it means the exact same thing. Okay, then finally, what we're going to do is we're going to talk about what's called a correlation. So this is going to talk about which way our information is moving. So think about slope. We've talked about slope quite a bit. If I had a line that was starting up top at the left and going down, that would be a negative slope. If it started from the bottom left and went up, that would be a positive slope. Well, same thing with this. So instead of saying slope, we call it a correlation. So I want you to find a little gap in here, somewhere where you don't have writing, and we would say this is a negative correlation. And we can see that on the graph because our line of best fit, or our trend line, starts up top and then goes down towards the left. So we can see that it's a negative correlation. Another way to see it, or another way to say it, is that as our absences increase, so absences get bigger, more absences, you're gone from school more, the test scores are decreasing, going down. So if it's going down, that's like negative or bad, or down. So it's a negative correlation. So as our x's increase, our y's decrease, going down, negative correlation. All right, so we're going to flip our paper over to the back for a second. So I'm going to give you a second to flip yours over to the back, and there's going to be another table on the back that you're going to do. So if we flip it over to the back, here's our next table. I would like for you to go ahead and make a scatter plot based off of this information. So you're going to have to think about, first of all, what you want to count by with your x's and your y's. Make sure you label everything. Okay. After you are finished, I want you to draw a trend line for your information. Then when you're done, we're going to talk about our information with our shoulder partner. So I'm going to give you 5 minutes to draw a scatter plot for this table right here. Alright, so your scatter plot should look something like mine. Hopefully you've had a chance to talk with your shoulder partner about this and work together a little bit as you go through it. Now I talked to you beforehand, part of the directions were to draw a trend line. So remember, your trend line isn't trying to go through all the points. It's just showing the direction that all these points are moving. So this situation is very, very similar to what we had before on our graph on the other side. So your trend line should look something similar to this. So something that shows that our information is decreasing. Okay? So from left to right. Again, if we think about what this situation is actually saying, it's saying as the temperature outside goes up, increasing towards 100, the amount of people wearing coats is decreasing. And that makes sense because as it gets warmer, less and less people wear coats. So a couple of things we want to add to this. First thing I want you to write is this a negative correlation like the one we had before? Or do we think this might be a positive correlation where it's going up? So I'm going to give you a second to write that, and I'm going to actually have you write it down below. So put a number 1, and what kind of correlation you think this is, either negative or positive. Alright, so on 3 we're all going to say what type of correlation we think it is. So either negative or positive. Ready? 1, 2, 3. Alright, we should have said this is another negative correlation. Now, we've talked about negative a couple times now, so we're just going to sketch this. So negative, again, looks like it's going down. Positive correlation, if this is my graph, would be the information's going up. And then there's also a type called no correlation, and that's when our information is so scattered about that there's no way it even looks like anything. It doesn't look like it's going up, it doesn't look like it's going down. So this one, in this case though, like we said, is a negative correlation. Positive goes up, no correlation is all scattered out. Okay? The next thing I want you to do is, if there's any clusters, so remember a cluster is anything that's really close together, any points that are really close together, I want you to circle that cluster. So I'm going to give you about 10 seconds, see if there's anything that you would consider a cluster to circle on your scatter plot. So if we look at our scatter plot, one place that I would consider a cluster are these two points up at the top. So if you haven't already, go ahead and circle those, and we're going to label that a cluster. So those 2 points would be really our first 2 points, 525 and 1224. So as the temperature changes just a little bit, the coats stayed the same, basically. Just changed by 1, so that's a cluster. Are there any outliers that we see? So I'm going to give you a second if there's anything you would consider an outlier. So it kind of looks a little bit off, doesn't quite fit our information. Go ahead and circle and label that as an outlier. Okay, so let's talk about this. Looking at my graph, really the only one I would maybe consider is this point right here, which was 30 degrees outside and 23 people still wearing coats. But if we think about it in the course of our information, our temperature is getting higher, 5, 12, 30, and our people wearing coats is still going down, so it does fit our information, but it's still kind of off our graph a little bit, or off our trend line a little bit. So let's circle that. We're going to call that an outlier. Alright, so hopefully we have gained a pretty good knowledge on scatter plots, just the basics. You're going to have a page to work on now on your own, or to take home for homework if you don't finish. Alright guys, good job today. Have a great rest of your day.